Okay, we got another update from our resources on the assays. Came back for the new Boston project. So I'm just sharing the press release that they came out with. What did we want from New Boston? Well, number one, is there something that has massive values and makes shareholders rich and develop a mine for the area? All that stuff. Number two, is there maybe a high grade zone that we could find, and that might create a mine in the future with helping with IIR, quick payback, something like that that just kind of ignites that project. And based on what we have in these results, I would say that the answer is no to both those questions. I think most people would agree with me at this point, but we do have information. We have more pieces of the puzzle, if you want to call it that. How, is the puzzle getting close to complete? I would probably say it's like 80% complete is where we're at right now. So, what do we have here? So, yeah, Justin was right when he said, he expects to see copper from the beginning of the hole all the way to the end, and that is true. So it definitely is fertile ground. There is metal everywhere, especially in areas that we know that the magma pushed up. But how much, concentration, how much metal is there? It is kind of what we want to look at. So, I mean, look at these, these samples, these holes that they've done. I've just done some rough calculations on the top. Looking at the entire hole and then averaging the entire thing doesn't make a lot of sense. It doesn't tell you a lot of data. Um, Tells you a little bit, but not, it's not. I need to go a little bit deeper into it. But for the first part here, where we look kind of at the entire hole, you do the math, and it's like, I calculated $9 to $10 US rock value, if you want to call it that. And an open pit mine, yeah, that's not going to make money. So that just, it tells you there is mineral there, but in this climate, this commodity world we live in, that's not going to cut it. But that really doesn't tell you anything because it's too averaged. So we can look at the second part here. And if I do math on these, I'm getting close to, US $17 per rock value. So we're getting, a little bit closer. So my concept of kind of potentially a small open pit in the east zone at the top, where there's kind of like minerals everywhere, and a small open pit in the Jeep zone. That's still in play in a world where copper and molybdenum prices go way up. You might have two small open pits here just on what we have. But today, right now, we don't really have that value to see. So yeah, so those are kind of the results. They did provide this nice graph here, so we can kind of see copper, silver, and moly. And again, as earlier, as I said, when you do the math, make sure that you understand that this is molybdenum, the element, not MOS2, which is the sale product. So this is similar to what one of the earlier, drill hole assays in the Jeep zone did. They were kind of mixing moly and MOS2, so you really had to understand it. So this is purely the moly is what we get, and that's kind of what I used for the math up top with the rock value. Okay, so one thing, we'll get into a couple of little sketch drawings. But you'll notice that on the left-hand side, you're getting a lot of the Q for quartz here, and you're getting a significant amount of that. And on the right-hand side with the drill hole number 2, you're not really seeing a lot of that. You're seeing a little bit down the road, but you're seeing a lot of the other stuff, and you're seeing a bit of a grade difference as well, right? Seeing a little bit more copper here, and then variable here. So we'll get into that as well. But what are we seeing here? Well, if we get into one of the classic, you know, copper porphyry diagrams that is everywhere in the web, um, you kind of, and this is kind of what I was like, well, you know, a lot of the diagrams say that center part here is kind of maybe mineralized, but it's not really going to make you a mine. And what you get is, you know, you get the ores coming up, you know, on the right hand side and the left hand side. Really, this is kind of a circle, so it wraps completely around that potassic boundary. So how I like to describe this is that initial, you know, eruption from the middle, let's say, going up through the, you know, the potassic. Yeah, everything travels with the, you know, the path of least resistance, right? And what I want to probably imagine is that, yes, we want to grab a lot of that minerals and all that stuff that's in the magma deeper down in the earth, and we want to send it up through the earth. But I think when the minerals get deposited, what you actually want is resistance. Okay, that makes sense. So yes, you want the path of least resistance, but the more resistance you can have along the way, the more chances that you're going to get deposited into that. And then if you have other eruptions that go in there, near there, it might deposit more and more and more, and then you get a concentration. And I think that's basically what's happening here. Is why you get the ore on the outside. You get the initial eruption up top, going right through it, and then on the sides you get multiple eruptions where it's going to travel the path of least resistance, which is actually going to be around that original eruption and going up through it. So um, that's pretty important as well. And then the other thing that I want to talk about is the country rock. We really haven't been exposed to what that is. There's just so much mineralization in this area, and you do the research, it's all about drilling into the mineralization. We know there's the limestone layers at the top, and then underneath that, at some point, you know, it's miscellaneous rock, miscellaneous sediment, miscellaneous something, right? So going through that as that magma, the initial magma comes up through this, you know, porphyry system, it's basically gonna, as far as I can tell, it's gonna melt the rocks, pushing it through up there, and then it's gonna do something interesting as it hits the limestones, because the limestone's going to be horizontally layered on top of it, so you know the dynamics of it is going to be different. And then I just want to bring up melting points as well. So you know, what is it going to do? And it's going to kind of go up, it's going to melt all that country rock as it gets closer to the earth, but it's got all this momentum, so nothing's going to stop it. But what does it do when it actually does hit that, you know, that limestone? So if I just Google melting point of rock, okay, so you can see that if we look at the Fahrenheit, 1100 to 2400 degrees Fahrenheit is basically what it is. So if we're hitting some country rock that, you know, melts at 1100, 1200, you know, it just joins with the molten and then keeps going up. Okay, so it's a big range because we don't know exactly what rock is. But let me look at limestone, right? Um, I don't know if anybody's thought, or like, what if we just put limestone in a pot? When does it, you know, when does it start melting, right? So you can see here on this page, the minimum is between 1500 and 2400 degrees Fahrenheit. So you know, it's in the upper range, like probably the upper 70% of the melting point of all rocks, let's say. So, and as that magma gets closer to the surface, which is where we know the limestone is, um, it is going to slowly, you know, reduce the temperature. So the chances that it actually is going to melt that limestone is probably a lot smaller. So it's probably going to go up there and just kind of you know, potentially react to it. You know, I think there was discussion about all that acidic fluid going up, hitting that basic limestone stuff. There's a lot of stuff that's going to happen, right? and it's just going to go up through there. And I imagine as it goes up, it's all these layers going left to right. It's not only just going to push through that and react with it, it's also going to try to squeeze through some of those horizontal layers, to the left, to the whatever, northeast, west, south. And I think we see that as it angles. It's really an angle. It's not straight up. So we can see that with some of the historic drilling as to where some of those minerals went. Okay, so that's kind of context as to what we're seeing in these drawings here. So if I get my little notepad, paint over here, okay, and let's make it orange. Why not? Okay, so this is the the initial reaction, right? And then I got all these limestone layers here, all the way down. Not doing a very good job. Okay. Okay. So the magma is going to come up from the bottom. Okay. And it's just going to go path of least resistance. However, it figured out how it's going to do that. It's just physics at that point. And it's going to go through here, melt all this rock through here, go up there, and then hit the limestone and react and squeeze through everything before it hits daylight and does whatever it needs to do. That stuff's probably been eroded, whatever happened up there. So we definitely have this, this change as this, and if this is eruption number 1, this is that cross, the vein A, where we're not. It's kind of like the in situ. So this is gonna, in some ways, this is gonna be your. It's gonna have minerals, but it's probably gonna have the in situ raw lowest grade minerals there. Okay. And then what happens now when you have more eruptions, it no longer has that. It's just physics, and we have these weak spots actually on this orange line here, and that's a circle really if you look top down on it. So it's going to come up around the quartz porphyry system, and then it's going to start depositing. So what you end up with is oh, I'm still on the arrow. That's fun. You end up with eruptions that kind of go along like that. I'll just do one by one on the side. Right. And then again, I mean, there's still definitely going to be a path of resistance here. It's just going to look kind of weird, and it might squeeze through the limestone as well, right? Okay, so you get what I mean here. Okay. So, in the other diagram, the purple is going to be what they call the ore, right? So, if I were to put a value, right? Because we do have some assays now. What does that mean, right? So I'm going to just put here, if I look at the raw area here, really, I'm just going to say $5 US per ton in this area here, okay? And then in this area here, and in the limestone, especially as we hit here, I'm going to put $10 per ton. Let's see if I can get that in there. Okay. And then as we even get closer to the top, we've seen kind of historic holes, in this whole thing. I'm still going to increase that to $20 per ton, as sometimes I'm using units, sometimes I'm not. Okay. Okay, But what about this, this purple stuff here? So, if I were to, let's just circle this. Let's see if I can. So this $20 zone, let's say, is there. This $10 zone, let's say, is there, and then this $5 zone, let's say, is there. Okay. Now, again, in the press release, when we had those longer intersections, it comes up with $17, per ton. But I think it's more, this is how I would model that. I would not look necessarily at the averages. And if we actually zoom in on these things, what we're actually going to say, like if I take a box here, okay, if I take a box there and I put it over here, what we're going to have here is oh, there we go, I forgot to go to the line, is we're going to have different zones here, okay, like that, okay. And if you actually look at the, the graph that we sent, we literally have, we are hitting some mineralization in some of these zones here, right? So in a very small section here, we actually have, see if I move that. There is, in that press release, is showing a section, potentially in here or up here or whatever, that is $1,000 rock value. The problem is it's very narrow. So then we might get something like, $100 rock value, right? And this is, it is kind of, modeling into that, that drawing that we did see where we do have the ore coming up these sides here, right? But the game you play is like, how do you mine this? Is there enough metal to do that? And if you look at various projects, if this is a west to east section here, the west side ore coming up could be thicker, could be higher width, could be more metal loaded, deposited there, versus the other side might have less. So it's interesting, and I think we definitely are missing some data points on this project, but how do you get those data points? So in the reality, this thing actually goes up to surface like that, right? So, I mean, my guess would be, the stuff at the top and the stuff, at the bottom. And again, but this is still a circle, so we're still only getting section. But, magma is going to go up. It's going to want to go, even though it's going to go against this, it's still going to have an upward pressure, right? And on this one, it's going to have an upper pressure onto that. So, and this modeling, I'm going to see a very different set of physics happening in this case versus this case. And I think, if we look at this deposit, we may even see some things going up to the top here. And I think we've seen that in some of the, the Gaussins and stuff at surface. So we may still have some where it hits some weak stuff and it goes up here. So I'm very curious as to some of this might be a data point, and then this would be another data point. But did we capture all the, how much data points did we capture or not? So this one is, it's hard to validate what we're seeing here in the purple. What's that rock value? Can you mine it? Is there any mineable techniques that you can do to get it? Um, I'm just thinking outside the box. Over the last 5 years, there's been I wouldn't say a push, but trials happening with ore sorting so that you can go and drill blast the pit. If you see huge chunks of ore, it basically on the conveyor belt, it just shoots them to the side, and then you're left with a more highly concentrated metallic stuff that you would then send to the mill. So you're basically um, saving costs on, trucking that, the concentrated material, saving costs on milling it, but you still have to drill and blast it, and then there's an additional cost of ore sorting. So yeah, this, I mean, this, in the future, this might be one of those cases, maybe not. Um, but I wouldn't do a huge open pit here and send every, chunk of rock into the mill. I don't think it would ever work here. So um, we'll see. So yeah, so that's where that is now. Let's look at the results and see if what I'm talking about here with this like $5, $10, $20 stuff. So let me get here. Okay. So what is quite interesting on drill hole number one is that material. Um, like I'm saying, it's where is that drill? Let's go look at the drill hole. So the drill hole is kind of in a little bit outside the mineralized box, but eventually gets into the quartz pretty fairly quickly and stays in the quartz area for most of the way here, right? Um, but talking about melting points and all that stuff here, what we know is that as that magma goes up, at 300 is when it hits that limestone. And from that limestone all the way up, as it hits more resistance, as the temperature starts dropping, as all that stuff is reacting with the limestone, guess what we're seeing here? So this stuff below is kind of the pure quartz porphyry that the magma's come up, probably melted the rock and just continued through. And we see a distinct change at the 300 meter mark, where you see there's actually more copper being deposited from there all the way to surface, all the way through that limestone, up through the limestone, squeezing out maybe to some of the limestone horizontal layers. And then as you get closer to the surface, you're getting kind of more nooks and crannies and opportunity, I think, for that metal to deposit out. Plus, where that hole, is coming from, right? This stuff up here would also be fed from the multiple eruptions on the left hand, right, left hand or right hand of the magma porphyry system, right? So you're also getting that as well. We talked about how that gets pushed, and then this whole area here, we're seeing a lot more mineralization on the surface. We had looked at that, so I think that's what's happening as well. It's getting pushed through those limestone layers, and we're seeing residual material there. And it has multiple eruptions. That's maybe why we're seeing some grades here, 0.38% copper here, uh, all that good stuff. So that's we're clearly seeing it when it hits the limestone here. So if I look here, this is kind of like the generic $5 rock value. It's just kind of the virgin original magma eruption. This is kind of like how much minerals are in that magma. It tells you that this is kind of like the base. This is a starting point. And then as more eruptions and deposits, you're going to just go up from there, really, right? So this is kind of just like the base starting point. $5 rock value I was throwing at it. And then, but then the theory goes, as you get closer to the source, does as it's, I don't know how it worked way back when, is there more metal as you get deeper? And I think we're seeing, this is pretty pretty average here, and then you are seeing a little bit as you get, deeper into the option. And then what we see in the Jeep zone is that, yeah, you have a lot of mineralization on top, then you kind of have a dead zone, and then you get moly increases at depth. And definitely we are seeing that here. On the right, you can definitely see that all of a sudden we have the main quartz porphyry pipe, but as you get lower, all of a sudden you're seeing the moly increase, and moly is worth a lot of money still. It's still part of the economics here. Silver is interesting. They kind of said it in the press release, average 1 to 2 grams per ton. Again, that's $1 to $2 rock value. Um, this graph, I mean, like, I don't know if it's just kind of bleeding, but this looks more like $2 to $3. So I'd be curious to see the raw numbers there. But it's also, variable. You get little spikes at different times as well. So that this, again, so the top bit is a representative of the initial magma blast into the limestone. This is kind of what you're seeing. As you get lower, this is kind of just like the raw magma hitting the country rock, melting. This is kind of what you get left over. And then as you get deeper, you're seeing a little bit more mineralization. It is kind of, I think, moving over a little bit on the one side, so that may be as well be it. But yeah, it's very just information, really. That's all you can do as well. And then on the 002, well, first of all, we knew that we were gonna get some grades in the top half because we could see that with some of the historic things, and that's going through the limestone. But you can see that it's going through maybe that what we see in the diagram is kind of like the ore section um, as well, and then kind of we see some quartz here, and then you can see it again. It flares up when you do hit that section. Okay. Um, so this is kind of it's not really. It's interesting because I think you're based on what we'll see with the drill hole. Usually, when you want to look at these things, you kind of want to cut across the ore. So you get true widths and you got sections here, and I think this kind of bled into the opposite, where it was kind of going with that. So you're getting information, but it's not as cut and dry as like, oh, you cut through this quartz vein and you cut through this quartz vein, you cut through this vein and you cut through this vein. There's a 3D component here, and I don't think the data points is like, yeah, there's minerals there on wherever that 002 is going hole is going, but there's no way you're getting true widths or what the actual veining is from this. So now, if we take a step back to just drilling, so drill holes, all drill holes in the entire world. Pick a project, pick a rock type. It has a natural deviation. And this is why we do downhole surveys. We drill the hole and then we also survey the hole after. So we understand, did it turn? What's the azimuth? What's the dip? Okay. And, if I look at, the 002, well, I mean, this is not where it was designed to go, really. And you can see that with the slow paced drilling and they're throttling and not pushing it hard and not pushing a lot of pressure, that in itself probably gives it more prone to deviation than if you were able to just punch it through with high pressure, high energy, go go go. Would have been what would say would be a straighter hole, even though it would still deviate. But I can see that we're getting a banana shape, right? We're getting a banana shape here, and on hole 001 we're getting a banana shape here as well. So that tells you the natural deviation goes exactly that way. So probably in the entire project, that you can kind of start understanding how the drill hole is going to deviate. And again, so this is 002. I believe the original design was to cut across and go, over in this area, and it just bailed and went to the left, which is why in my little drawing we're probably getting more of this, where it kind of goes here and then it comes down here. We got some of the quartz things, but we got all these types of things, and we're kind of going with the grain instead of against the grain. So we're still getting that information. So, like for example, um, we're kind of going this like that. In reality, if you wanted to get precise measurements, you're never going to get this. And this is the fundamental things where um, you can try to kind of, I think they were, like different angles will give you different information. But even with the curvature, they're kind of going like, this is probably exaggeration, right? You're kind of going with the grain, and then the standard deviation is probably, or I don't know if it's called standard deviation. Sorry, drill hole deviation is probably not helping you with that. So again, so this is why we have some pieces of puzzles, but there's still some pieces that are not there. Um, so basically in the previous presentations, I'm like, well, the next thing is what are those mag targets going to look like? And one of the dreams was like, could 002 be a kilometer, 1,000-meter hole? That's dream. Those are called $1,000,000 holes because logistically, they're actually, as you get deeper, you're going to run into problems, and there's not that many holes in the world. And there's not that many geologists or explorer companies that want to drill those things if they can avoid it. So this might have been an attempt to get a 1,000-kilometer hole, and really it was trying to get down here where we have that fault there, we have something here, and we have magnetic targets down there as well. So we're missing, that's a data point we don't have. What is the magnetic targets? Is there a higher concentration of metal, so much concentration that you can get $200-300 rock value, and then you can get a mine going, an underground mine going, right? At this point, you're not going to say, oh, we're going to target those magnetic, targets. Hopefully there's a lot of metal there, and hopefully it's, 0.5% copper EQ. That's not what you're looking for at that point. You're looking for concentrated metal in, whatever, 2 to 3% copper equivalent range. But we're still, nobody's, this fault's a question, that angles, those magnetic targets really are still up in the air. Nobody's really understands them because they haven't really drilled deep, even with the Jeep zone there. So with the mag survey they're going to see the mag targets here. I believe it targets here. There is a big fault here, and I think that goes with the green line there. So I think they should extend the mag survey out here to see if that magnetic material got shifted in the fault. How old that fault is, I don't know. But if they had magnetic material out here, let's say, in theory, drilling into that target from over on the east side here would be a lot cheaper because the mountains go down. You're actually starting at a much lower elevation, and you can drill into that target. So that's what I want to see out of this the mag survey that they'll be doing in the next, I don't know, 3 to 4 months. They have a follow-up here. Like this is definitely, as this, I think the Jeep zone is basically what I said early on in this call, path of least resistance, but you eventually want to hit that resistance. You want resistance to be able to deposit minerals. So I think that's basically what the Jeep mine is. There's just a lot of fluid came up here, but it just like smashed everywhere. and there's resistance everywhere and limestone layers still going through there. Probably a lot more material came up through the Jeep zone on the west side of the fault than ever did come up on the east zone. So in general, probably there's a lot more metal there. Um, but looking at the old assays, there's a lot of noise because there is that much information in there. So if they do follow up here and do a drill hole here, again, can they target to go through that mineral zone? Can they target that conductivity there, and then can they find a magnetic zone to go there? That's again a huge wish list of not only firming up a drill hole, but actually executing. Is the Jeep mine? There's a lot more drills in here. Is it that much easier to drill hole through than what they found in the east zone? I don't know. Um, but yeah, so it's information. There wasn't a home run hit. There wasn't a high grade zone um, in what they found here. There's a couple pieces of puzzles left. The magnetic zone here, getting this Jeep mine down here, getting a new data point for the mineral chemistry in here, because all of it's just old assays. Be good to put it through modern day lab. Hitting the conductor here, is it going to be the same quartz porphyry? Is there going to be ore type material, mineralized material around it? And then can they hit a magnetic zone as well um, on that? So, and then we have the conductive target up here as well. So that's another interesting target. Um, but I mean, how much money do you spend? How much time do you spend? Um, I think do the magnetic survey, see if you can get some, the previous mag things are, very chunky. It's not very detailed. Enhance that data, see if you can get, where is the depth of that? Where is that? Make it a target. See if you can find a logistical way to, increase your chances to actually successfully intersect that target, and then go drill a hole. I mean, and I think that's it for New Boston, and then see what you get. That might be kind of like after that, if you can drum up enough money to go and actually execute this, and you like what you're seeing in those make targets, execute it, and then see if you can find those high grade zones that kind of may pay for a project to start. Otherwise, this project eventually might get shelved. I think it's still worthwhile. I think to work on this a little bit further, do those mag things, see if you can get something there. If it's still chunky, it's still going to be a tough sell to go and drill. You could just do the follow up and focus on the Jeep mine and get the latest and greatest technology into it, and see what you can get. I think it's just a mishmash of minerals in there. So yeah, like I said, in the end, in the next 20 to 30 years, if you want to look at that, with the world going the way it is, you probably have a open pit here, small open pit here, and then who knows after that. But there's a lot of other submarginal deposits in the world, so it's based on what we know today, it's an uphill battle for New Boston. Again, you got to look for those the high grade zones that really make the project something. Um, yeah, this I can't put a value on this. The stock price has gone down. Again, I try not to predict stock prices. There's a lot of moving factors into the sentiment across the sector. A lot of my juniors were kind of poking up in March, April. There was a little bit of optimism, and now it's just completely gone. Not just VR Resources, but some of the other stocks I have with profitable projects that are on the books. They're just getting killed just as much. So
just kind of, wait. If you need the money, you can sell. If you want to accumulate, you can accumulate. Again, I'm really looking for some juicy targets in Ontario, some nice anomalies to get me excited. Um, those bullseye targets that are grassroots. This is kind of brownfields, I would consider, because we know there's minerals in there and there's nothing to make a mine in the past, and we find some relatively new targets, but I would still call that brownfields. I'm definitely a sucker for the grassroots targets of like, oh, here's a nice round circle. Nobody's drilled in it. We don't know anything about it from distance. We can make some theories based on regional information. Let's go drill in there and let's see what we get. I mean, that's pretty exciting. That's kind of how I want my juniors to play out. Boom or bust, and go from there. So I think they're going to spend a lot of time in Ontario as well. And I don't see any necessarily drill programs in the next, 2 to 3 months. I think there's just going to be a lot of geophysics work on multiple projects, and as long as they can, find me some nice, crisp targets, I'll be happy. I'll just continue on, and then we can look at drilling. But I mean, there's probably no rush to go out and, buy shares today if there's not going to be a catalyst, for 3 or 4 months, other than the fact that maybe people think the price is so far depreciated that, it might get a bump up. I don't know. I try not to predict where things are going. I just can own whatever X quarter percentage of some company with projects that I like, and hopefully with some execution and some, you don't want to say luck, but hopefully you've increased your luck chances with all the homework that you've done. And I mean, that's one reason why I do like VR Resources, because they do a ton of homework. When I did met Gunning, he had his work laptop and he was working late the one day, and I'm like, oh, yeah, that's a good sign that you're not just in a company with a recreational CEO who's just collecting money and going to a beach. No, VR Resources is carefully spending their money, doing a ton of homework on these projects, followed up by very selective execution. And it's the junior sector, so it's all speculative, but you have to have minimum bars, and then hopefully in the future you get success. So that's my tidbit. Probably if I'm going to do another video, probably won't be on New Boston for another 6 to 12 months, if that. But let's see with Ontario, if they show me some geophysics, I might put out a video for those projects, especially if there's some nice round, large, possible kimberlite targets. I'll be all over those. Until next time, enjoy your day.